Welcome to qnawire.
So now we'll work on problem 10 from chapter 17. In this problem, we're told that calcium hydroxide has a KSP of 6.5 times 10 to the minus 6. And in the first part, we're asked if 0.370 grams of calcium hydroxide is added to 500 milliliters of water, and the mixture is allowed to come to equilibrium, will the solution be saturated? So we know that saturation of a solution occurs when Q is equal to KSP. If Q is less than KSP, it will not be saturated and there will be no precipitation. So our KSP is 6.5 times 10 to the minus 6. So we can go ahead and calculate the concentration of calcium and hydroxide ions and then calculate Q. So we have 0.370 grams of calcium hydroxide. And then we can divide by the molar mass to get moles of calcium hydroxide. And then we divide by the volume to get the concentration, which is 9.987 times 10 to the minus 3 molar. And so the concentration of calcium will equal this value. And the concentration of hydroxide will be 2 times this value because of the stoichiometry. So if we calculate Q, we multiply 9.987 times 10 to the minus 3 times 1.997 times 10 to the minus 2, which will be squared because of the stoichiometry again. And the value we get is 3.99 times 10 to the minus 6. And we see that Q is less than KSP, so it is not saturated. So in part B of this problem, we're asked about if 50 milliliters of the solution from part A is added to any of the beakers shown here, and which beakers, if any, will a precipitate form. In those cases where a precipitate forms, what is its identity? So we can go ahead and look at the first one here. We see the first two beakers are filled with, first is HCl, the second is NaCl. So I is HCl, and the second one, 2, is NaCl. Now here, we don't have a common ion effect. Calcium hydroxide has no common ions to either of these two compounds. So for these two, there will be no precipitation, since there is no common ion. For 3, we're shown a beaker of 50 milliliters of 1 molar calcium chloride. Now this does have a common ion, which is calcium. So what we need to do is do the same process we did for part A, where we need to calculate a new concentration of calcium and hydroxide. So we're going to use 50 milliliters of the solution and from part A, which means that we're going to have we can multiply our concentration of calcium, 9.987 times 10 to the minus 3 times 0.050 liters. And this will give us 4.99 times 10 to the minus 4 moles. And then we had from the 50 milliliters of the new solution, which we'll call the third solution, we're going to get some moles. It's 1 molar calcium chloride times, again, 50 milliliters, or 0.05 liters, and we get a value of 0.05 moles. So for our new concentration of calcium, we add these two values and divide by the new volume. So we get 5.05 times 10 to the minus 2 divided by 100 milliliters, or 0.100 liters. And this is equal to 0.505 molar. And the concentration of OH is simply 2 times the concentration that we calculated above. So 4.99 times 10 to the minus 4 times 2 gives us 9.99 times 10 to the minus 3 molar. And so we calculate Q here as being equal to the concentration of calcium times the concentration of hydroxide ion squared. And the value that we get is 5.03 times 10 to the minus 5. And so what this means Q is greater than KSP. So we have a precipitate form, and the identity of that precipitate is calcium hydroxide. Now for part 4, the fourth part of part B, we're told that the solution that we have now is calcium, 50 milliliters of 0.10 molar calcium chloride, so a lower concentration of calcium chloride. So we go ahead and do the same thing that we just did. We calculate how many additional moles of calcium chloride we're going to have. So 50 milliliters of this fourth solution is 0.1 molar times 0.050, and that's 0.005 moles. For the concentration of calcium, we add it to the previous amount that we got before, which was 4.99 times 10 to the minus 4. And when we add it together, we get 5.49, 9 times 10 to the minus 3, that's moles, divided by 0.10 liters, and that gives us 5.50 times 10 to the minus 2 molarity. And so the concentration of hydroxide remains unchanged, so Q is equal to 5.50 times 10 to the minus 2 times 9.99 times 10 to the minus 3 squared, which gives us a value of 5.49 times 10 to the minus 6 for Q. So in this case, Q is less than KSP, which is 6.5 times 10 to the minus 6. Q is less than KSP, which means no precipitation.